The user has generated content, so what now? My name is Bartosz Studnik. I am video engineering lead at Flip. Flip is a social commerce platform, so something like TikTok but for shopping. But we build it everything from scratch. Our content are the video reviews, so users buy our products or on our store. Then they make the reviews, the video reviews, so they upload the files to us, and we are processing them. And well, what I'm trying to do in my job, I'm trying to make the videos rather like the one on the left than the one on the right. Yeah. Today on my agenda, we'll speak about this mysterious content. Yes. So the videos that actually our users are sending us, well, sometimes they are not very technically appropriate. So we'll speak about it. I have some examples of it. Then we'll speak about how our approach, so how our video processing pipeline actually needed to be changed according to this mysterious input. And well, we'll speak about some other challenges that the user-generated content, well, environment, this whole world actually requires from us. So we're all here because we love video, right? Or at least we are interested in it, yeah? But what would love be without the pain you need to go through, right? So all the problems, all the issues, the artifacts, the broken videos, not playing videos, empty manifests, and so on, right? So yeah, I have some examples of this mysterious content, so let's start with the first one. Right, where would the fun be if everything was so simple, right? So let's not be negative, but let's make it a challenge for us. And actually, it's super satisfying when you have really crappy content and you actually manage to process it. So the first one, I call it the silence, right? Because, well, the user uploaded the video. It had sound indeed, but we processed it and there was no sound. So what would you do in such case? Well, definitely check some FFmpeg output, right? Play the video actually with some player and check the manifest. We are delivering HLS manifest, so we are checking this one. So yeah, even though the manifest said, well, everything is all right, the audio is there, well, there was no audio in the playback, and the FFmpeg gave some unusual output. So as you can see, well, there was some weird audio codec, actually, and the only information that we knew that it is a PCM audio format, but well, there's a problem. There is a bunch of PCM audio formats, and if you do it wrong, well, the good part is that we didn't have sound, because the other part is that you have such glitchy sound, really terrible sounds, and I needed to go through all of them, not pleasant experience. So we needed to figure something out. Where our solution is adding a new tool, which is EXIF tool, maybe you are familiar with it, but it doesn't really solve the problem at all, because it just adds some more information about this format. It doesn't really tell us what's the case. So later, based on this PCM audio new metadata, we need to determine which exactly format it is. And well, we need to change it to some friendly format like AAC or Opus, right? So moving to the next one, I call it Jumper. I played a video in a second. Well, the video was jumping. We were missing some frames. So I slowed it down for you so you can easily see what was happening. Yeah, exactly. I hope you have seen that one. Is it visible? Yeah, pretty clear. So what was the case? When you are packaging video, you are expecting segments of the same length. The manifest is saying, yeah, everyone is 2 seconds, right? But not in our case. Well, the segments were, in this example, 5 seconds long, even though the manifest said they are 2 seconds long. And sometimes they were 20 seconds, 30 seconds, 1 minute. Well, it really depends on the content. And what our players said, okay, 2 seconds is 2 seconds. So it was playing only 2 seconds of this 5-second segment and was skipping the rest. That was causing this jump. And some other player, by the way, was playing it just as usual. So it didn't really care what manifest said and said, okay, I paid for the whole segment. I'm going to play it all, right? So But this is just a side effect. It's not really the case. It was not, in my opinion, it was not the problem with the player. So it was the timing issue. Yeah, we all love timing issues. So the green line on this visualization is the presentation timestamps, the PTS, of the regular video. Yeah, it's just rising. It's monotonically rising. And our jumper video was dropping, which should basically never be the case. And FFmpeg wasn't handling as well. As you can see in this example, the frame number 2, 5, and 11 wanted to be displayed at the same exact time. Well, that is technically not possible, probably. So that was the case here. So resetting the PTS helps most of the times, but not always, because when you have, for example, variable frame rate videos, you cannot just guess what frame rate is at a given moment of time. So it's not the case here. So moving on to the next one, pretty similar. I call it the single framer. I see my team is already smiling. They love this one. It's not necessarily single frame, but yeah, this is the whole content, the whole video. It is some still image, beautiful, super low quality, and some music in the background, right? So the case here is pretty similar. Again, the timing problem, but as you can see, in this case, there is some kind of pattern of here. So frames 1 to 6 in this example and 7 to 12 have exactly the same presentation timestamps. I think someone thought that looping a video looks like this, but it really doesn't and shouldn't. But why the video was shorter? Because, well, I didn't say that the video was actually shorter than the original, right? That was our symptom. So we have the original video, for example, 10 seconds long. The PTS starts to loop in some moment, and the rest was actually skipped. So again, resetting the PTS actually helps here, but well, I don't even know which kind of program is able to make such output. I was trying to reproduce it, and yeah, no luck here. FFmpeg just told me, go away, man, it's not possible to make such PTS. Okay, moving on to the next one. Yeah, beautiful dog. I call it empty framer because, well, we have beautiful footage on the frame number 1. Then we have frame number 2, which is empty, not necessarily black, sometimes green, red, yeah, it depends, and so on and so on. And that was our content. So it's really hard to notice, actually, when you're looking at it, it is a high frame rate video. Sometimes it's really hard to notice with your bare eye. So the case here was that the quality was super low and the bitrate was super high because the compression between the frames was actually not existing, because what do you refer to? The void, right? So yeah, that was the case. Fixing these videos, removing the empty frames, actually, as you can see, the quality was much, much bigger and the bitrate actually dropped. Right. Sometimes there is a problem with color. So on the left side, you can see the video that was processed by us, and on the right side was the original. I have some more examples that you maybe can see it much brighter what was happening here, right? So HDR to SDR translation is not always straightforward, and well, you need to handle it somehow, right? And it's not straightforward, especially when you have a ton of combinations of the parameters that are related to colors, right? It's pixel format, color spaces, and so on and so on. Well, we need to deal with it, but sometimes it's not just straightforward. Sometimes it's the user's encoder. Yeah, this is some test video, beautiful frame, and some broken frame. And actually, the whole video is broken because there was no iframes later to reset the stream. So each frame was referring to this broken frame that you can see in the middle, and well, the whole video is broken. Of course, we can do nothing about it, but actually you need to deal with such content as well. Yeah, we are receiving such videos, and we need to tell the user, well, sorry, it's not us, right? So what else have we made? I think the variable frame rate is my favorite, and we had a video that was spiking from 0.1 to 80,000 frames per second in one single video. We had a video that was much more had much more frames per second, by the way, but there was no such a big difference, right? So metadata different than the encoded bitstream. I love this one. Empty move atom, missing move atom. I don't know how users are playing those videos, but they were saying that they can play this video. I don't know how it's possible. The variable resolution, yeah, I know it happens sometimes in live streaming, but our users proved us that the variable resolution is also possible with static VOD files. So yeah, again, something unusual. Streams length, right? The MP4 file says it's 10 seconds long. The streams actually are much different length, and the output is even different length of any of those, right? Multiple video streams in single file. Okay, sometimes it's actually the case, and we need to handle it. But sometimes those are two separate videos and one audio stream. So yeah, please, Mr. Encoder, pick the best one. Basically, that's it. Unknown stream types. Well, even though there is nothing in those streams, the FFmpeg was processing our videos for hours instead of minutes, right? Super weird thing. And trust me, many more. I could probably go here for hours to speaking about what went wrong, what mysterious content did we receive. So yeah. But how did our processing pipeline change according to all those challenges? So at the very beginning, it was pretty straightforward, right? Some video upload, some brief analysis, and encoding and packaging in one step, by the way. So a lot of things were happening in this last step, so encoding and packaging. So we needed to deal with all the things that I just mentioned to you. We needed to prepare the content, so the HDR to SDR translation, this weird audio format, and so on and so on. Well, that was super difficult to actually maintain. Debugging was a real nightmare because anytime something went wrong, we needed to evaluate the whole thing again, and it was super slow because there were no parallel steps actually. So what we've done, we enhanced our video processing pipeline by extending our analysis step. So we extracted a lot more metadata right here. We added a new step which we call normalization. So what goes in this crappy video, right? And what goes out is something that is ready to encode, to process, and we don't need to care about all those stuff. So single point of failure. Then we are just doing the regular things, so write some thumbnail GIFs, encoding packaging, right? It's orchestrated by our microservice. And well, later we measure the video quality, so we are using the VMAF Netflix metric for the video quality. And well, what I think is unique in our video processing pipeline is that we verify the packaged output. So what we are doing is that we are fetching the manifest, the playlist, the segments, and we are making a bunch of checks on them to actually make sure or just check if the video is going to play well, right? So we are doing our best to actually, before we deliver the video to the user, we are making those checks to actually look at this content, whether everything is all right. So this step actually saved us a lot of time because most of the issues that I've just presented to you were discovered by this exact piece of software. So a pretty big value coming from there. So what are challenges are here in the UGC world, so user-generated world, right? So users scroll fast, like you know, when you have the TikTok, YouTube Shorts, things like that, you're just scrolling. And well, our videos are short as well, up to 1 minute. So the users are also scrolling really fast, and we need to deliver this video quickly. We have the product reviews. We cannot chip out on the video quality, right? There is no way to do it. And well, the user also wants this video to be processed as soon as possible. So yeah, we need to process the video quickly. And on top of that things, well, we have this normalization, verification, dealing with all this UGC stuff. the content is extremely diverse. So one video is super different than another, and actually encoding is a very big challenge. So looking at this problem from some other perspective, well, video processing takes too long, right? What do? We encode it quickly, right? So what happens? The video loads too slowly, and we need to spend more time on encoding. It's a cycle, one problem causing another, and we are not even speaking about the video quality yet. So we needed to figure something out. So as you can see in this triangle, you can only focus on one side of this. You need to make some compromise. So what do? At the very beginning, we are focusing on the processing time and the bitrate. So we are delivering the AVC stream. The video quality is, well, okay, but the processing time is as low as possible, and the bitrate is also okay. Later what we do, we are delivering the new codec stream. So as you can see, the video quality is much better, the bitrate is also optimized, but we are sacrificing a lot of processing time because it just takes longer. And what we do as last step, and we don't always do this, is the optimized encoding. So we only do it when we see that the video quality is low, or the content is or going to be popular enough. So it's a win-win situation. We pay less for the transfers, and the users are getting higher quality videos with lower bitrate. To do this, to achieve it actually, we use per-title encoding. And in my opinion, there is no other way around than using the per-title encoding for the perfect content in the UGC world. Well, per-title encoding is something that each video asset is treated differently. So you encode it with totally different encoding settings, right? And what we do, we don't really focus on the H.264 or the AVC codec because the gains 3 to 7% aren't really the thing that we are going for. We are focusing on the VP9, and we hope to use AV1 soon, especially after the latest Apple's announcement that they are going to support it on iPhones and the latest software. So I think moving forward to this per-title encoding, if you want to do this, you need to start slow. So it took our team around 1,000 of encodes to just have the basic understanding what is possible to achieve with per-title encoding. Yes, it was a brute force method. There are tools designed to actually do that for you, so find the best or optimal encoding settings. But to understand it, we needed to check everything, right? Everything that came to our mind, the resolution, the speeds, the bit rates, and so on and so on. And that is costly, right? Because, well, when you are encoding one single piece of content thousands of times, it takes a lot of time. So it takes a lot of server time. So it costs something, right? You need to understand what you want to achieve. So whether you want higher video quality, or you want lower bit rates, or you want the processing time. Well, maybe the processing time isn't for the per-title encoding, right? But you need to understand your content. And when we did the same thing for some other video, well, as you can imagine, the results were totally different. So that's the case. You need to understand your content and focus on the things that you want to optimize. And speaking about the optimizations, I think the last thing that I want to mention is that you can actually optimize beyond encoding, right? So a lot of things can be optimized on the client side, on the transport side. So what we are doing in our case, we are fetching the content in the background. So again, when you are scrolling this feed, right, you see the video number 1, and you are going to see the videos 2, 3, 4, and so on. And what we do, we are fetching those videos in the background before you actually see them. So again, when you are scrolling fast, you will receive them quicker, right? And our metric shows that over 90% of content is fetched in the background, and the video start time, well, they are really, really good thanks to that. And last thought that I have, according to the UGC and all those mysteries that you actually need to deal with, is the observability taking care about your errors. Well, when you have such a weird inputs, you need to take care whether they are playing, if they are buffering for some unknown reason. We had that as well. And you need to also understand how long the users are going to wait before the video starts, right? So this metric left before video start, or as maybe more of you know, exited before video start, right? So I think that was everything that I wanted to cover today. So if you have any questions, that's the best moment. I also will be around here today and tomorrow. And I have some bunch of stats in the background. So if you are not interested in the questions, we all like fancy numbers. So that's for you. Thank you.
Any questions? Okay, this one.
Yeah, thanks a lot. Very insightful talk. Also, a lot of it was very relatable. I've been struggling a lot with converting the HDR content to regular dynamic range. Do you have any tips for that?
We are using definitely the FFmpeg with libzinc. Maybe you are familiar with this one. So that was our solution for that. And actually, in my opinion, there is no other way around than reading those specifications. And well, as I said in one of the slides, where we have a lot of those color-related parameters and the combinations of them. So it's adding a lot of trouble here. And while we are just playing with it, trying our best to achieve it. So yeah, reading the standards, understanding what's beneath that. That's the best I can say right now, because that's a really long story, right?
Thank you.